Hello, I'm Chan Hongwei, and this is my teammate Francis Lim Jia. We are from Thai UC, Tunku Abdul Rahman University College, studying in BAIT 2004, which is Fundamental of Computer Network. Master Goldtech is a new manufacturing company that require to set up a small network connection. So we are invited to set up the network for the whole company lah. The location of the company is distinguished in LAN, which is local area network. So we have to ensure we are using the most efficiency and effective way in the design of the network. To achieve this, we choose to use copper straight-through cable and copper crossover cable, which consider under UTP, unshielded twisted pair cable, as the media of the network. The reason we choose these two types of cable is because this type of cable having the lower cost and providing the maximum data transfer rate and are able to support up to 10 gigabits per second. So what's the difference between these two types of cable, or we can say the scenario of using the cable? For the copper straight-through cable, it is used to connect the different device. For example, connect switch to PC, switch to router. For the copper crossover cable, it is used to connect the same device. For example, connect switch to switch. Okay, besides that, in the design of the network, we have separated it into 4 subnets according to the location of the company, which is location A, production department, location B, admin office, location C, sales department, and location D, warehouse. And all of these subnet will connected to only one router. As what I said just now, it is considered as a LAN network. So in a LAN network, one router is quite enough already. For additional, 4 switches are assigned to location A, B, and C, and there's only 1 switches assigned to location D. So what's the reason we do this? In location A, we need to assign 4 switches is because we have to fulfill all the needed of the device in the location A, which needed 18 hosts. So why 18 hosts? We need to assign for 4 switches. For your information, 1 switches are only able to connect maximum 24 devices. So we have 18 hosts. So we need to assign for 4 switches to fulfill all the 18 hosts, to make sure all the 18 hosts able to connect to the network. So for location B, we need to assign 4 switches is because it's in location B contain different floor, which ground floor and the first floor. 2 switches are assigned for ground floor as it have 34 devices, and another 2 switches assigned for first floor is to differentiate between the different department. In location C, we assign 4 switches to separate it according to the room, as there's 4 rooms is in location C. The purpose to do this is we will provide a good preparation for the future use. So the last location D, 1 switches is very enough as it is only contain 5 PC and 2 printer, which with total 7 device only. For the configuration of the network, we decided to design the IP addressing of the network start from 192.168.10.0 with the default subnet 24. So the VLSM method is fully in use to assign an IP address to every device in this network. So the purpose of the IP addressing is to build out the communication between devices, is to handle the connection between devices, and it provides a send and receive information across the network. IP address must be the unique identifier to every devices. So the network design I will pass to my teammate Francis.
Hello everyone, I am Francis from the TAUC, and now I'm going to talk about the network design of our network. So in location A, we assign 4 switches and 4 computers here, and 1 computer connected to 1 switch. The reason for the assigning 4 switch is because 1 switch only accepts 24 computers to connect with, but location A need to have active computers. As you can see here, we have active hosts at location A, which is production department. So that 4 switches are needed to connect all active computers. Beside that, in location A, 1 computer represent 20 PCs, which means that 1 switch is connected to 20 computers. So next, in location B, let's check the location B topology. So in location B, which is admin office, 3 switches are assigned accordingly to the different departments. Admin office is extended with another switch due to 1 switch unable to handle 34 computers. So the computer connected to admin office switch represent 24, here PC1 to PC24. And the computer connected to admin office 2 represents 10 computers. So the computer connected to accounting department switch represent 10 computers, and the computer connected to human resources department represent 8 computers. Okay, location C. In location C, the switch is separate accordingly to the room, and each room contains 2 computers and 1 online printer. Like all the computers in location C are represented to 2 computers, and the reason for assigning different switches to different rooms is to make the configuration and increase of device for the future more easily. In location D, the computer is represented by 5 computers, and each printer is represented by 1 printer. And all the switches are providing extra space for extending purpose for the future. So let's check the topology. For location A, which is production department, we have active hosts, and active host is 10% of growth, and the IP address of this LAN is 192.168.10.0, and the subnet mask is /25. For location B, we have 34 hosts, and 38 hosts is 10% of growth. The IP address of location B is 192.168.10.128, and the subnet mask is /36. So at location C, for location C, which is sales department, we have 12 hosts, and 14 hosts is 10% of growth. The IP address of location C is 192.168.10.192. The subnet mask is /28. So let's check location D. The location D have 7 hosts. The egg host is for 10% of growth, and the IP address is 192.168.10. Alright, let's check the addressing table. So as you can see, we assign the first usable address to the router port, which is gigabit Ethernet 0/0, and the second usable we assign to the switch 1 and assign it accordingly to switch 4, and then we assign the last usable IP address to the PC1 to PC20. Yep, this is for example 10.20x. The subnet mask is /29. Okay, so now let's try to ping in the network. Okay, so let's try this. We ping from location A 192.168.10.126, ping to location B. Let's ping to 192.168.10.156. Okay. Yep, as you can see, the ping is successful and it's reply. So let's try another one. We ping from location B to location C. So we randomly pick a PC and let's ping to 192.168.10.19x, this PC. So let's try now. So the ping is also successful. So let's try another one. We ping from location C to location D. We randomly pick one computer and let's ping to 192.168.10.212. Okay, which is PC1 to PC5. Let's try now. Yep, it shows successful also. Alright, so let's try the last ping, which is from location D, ping to location A. So here only got one PC, so let's pick this and ping to 192.168.10.x6. Yep, it also shows successful. So we also configure the password for router and every switch. So let's try. The password for every router and switch is syscall for the user access. Let's try syscall, and then yep, we get in. For the privilege mode, we need to enter a password again, which is BIT2004. Right, so now we enter the privilege mode. Yep, so this is our configuration about the password. Alright, that's all for us, and thank you.
Bye bye.